Good morning, everyone. Today we are going to present our final project for Networks 1. Our project consists of the design and simulation of a network infrastructure for the food court area at El Dorado International Airport. The main objective was to create a stable, scalable, and secure network that supports visitors, employees, and business operating inside.
First, we designed the network architecture. The topology includes routers, switches, servers, access points, and several VLANs connected through a multi-layer switch. The network was divided into three main segments: visitors, employers, and businesses. This segmentation improves organization performance and security because each group works independently while still allowing controlled communication between networks.
In addition, routers were used to manage traffic between the VLAN and provide internet connectivity. The multiplayer switch acts at the core of the networks, connecting all devices and enable inter-VLAN routing. This allowed users to communicate efficiently without affecting the performance of the entire infrastructure.
Regarding the structured cabin design, we use AutoCAD to create the distribution of the network inside the airport facilities. The total cable length was approximately 1,047 meters. The business network required the largest amount of cabling because it connects the main server area and the restaurant.
The calling was organized using cable trays and different color pods to identify each network. This helped us maintain an organized and professional infrastructure design. All devices converge to the multi-layer switch and then connect to the ISP router for external communication.
For the infrastructure section, we created both 2D and 3D blueprints. This model helps you visualize the physical distribution of devices, access points, servers, and network equipment. They also allowed us to verify connectivity and optimize the placement of equipment inside the airport environment.
The project was geographically based at El Dorado International Airport in Bogotá. Since the airport operates 24/7 and receives a large number of passengers, it requires a reliable and efficient network.
Now, talking about the equipment selection, we choose enterprise level devices because they provide high performance and security. Some of the selected devices were the Cisco Catalyst 9300 switch and Cisco ISR 4331 router, a Cisco Meraki MR46 access point, and a Dell PowerEdge R350 server.
This device supports multiple simultaneous connection, VLAN segmentation, wireless connectivity, and centralized server management. This makes the infrastructure scalable for future airport expansion and increased network reliability.
For the simulation, we use Cisco Packet Tracer to implement the logical topology. We configured VLANs 10, 20, and 30 for visitors, employees, and business.
The simulation demonstrated that visitors could successfully access the centralized web server used by the airport business. The communication between VLANs worked correctly and all devices maintained stable connectivity.
Finally, we analyzed network's performance using HTTP traffic test. The network shows 0% packet loss, stable latency around 4 milliseconds, and efficient throughput. This confirms that the proposed network design is functional, reliable, and capable for supporting airport operations.
In conclusion, this project allowed us to apply concepts such as land segmentation, routing, structured cabling, infrastructure design, and network simulation in a real world.
Thank you for your attention. We're ready to answer your questions.